Hello, testing mic. Can you hear me?
Yeah.
All right. Okay. Just a minute. Okay, let me message Aryan first. Okay, so Mike, electrolysis, right? So we're going to discuss electrolysis today. Any other updates on chemistry?
I don't think.
All right. So where are you at electrolysis compared to, Tuesday? Is there any progress?
We did the practical.
In what? In electrolysis also? Really? Oh, that's rare. Sometimes people don't have the chance to do, right?
We use like deionized water, put UI inside the
Yeah.
water, then touch
And
screen. Then we
then,
put it
yeah.
in YouTube. Then we sorry, not deionized water. It was deionized water with NaCl and NaSO4.
Yeah. That makes sense.
Then
Makes
we
sense.
run the electric current through it. One
Yes.
anode, one cathode.
Correct. Makes sense. And then bubbles will appear, right?
And then the Na side always turns purple.
Yep. It becomes more basic, basically, right? And then
And the positive side is either red or clear.
So either acidic or not sure what's happening, right? Okay. But is that all? Is that all the conclusion?
Yeah.
Oh, that's a bit unexpected, but okay.
I didn't really see the metal, or not the metal, but the,
What did you use as the anode and the cathode?
Anode and cathode.
Yeah, what did you? Yeah, the two metals going into the water, lah. So that's the anode and the cathode.
Right? Metals are they just provided us. They never said what the metals are.
Really?
Maybe
really?
Graphite. I have no idea. Yeah.
Now graphite is not metal, lah. So is it metallic or not metallic?
No, it's metallic. No,
A bit surprising, but maybe certain stainless steel a bit. Okay, never mind. We'll discuss the theory then you know. Okay, so I'm gonna have updates from Aryan. Any updates, Noah?
Not really.
Okay, all right. Any updates, Aryan, for chemistry lah? Aryan, I think you're muted. All right. Now, okay, and no need to set up your video for today, lah. At least not for now, right? So, Aryan, any updates for chemistry?
For chemistry, no.
Okay, so will it still be electrolysis next, and
Yeah, I'm pretty sure it will be.
Right. Then again, everybody, I'm waiting for the news whether OChem will be in. But actually, Noah already said that his school OChem will be in. Correct, Noah?
Yeah.
All right. Then very likely as for you, Aryan and Mike, OChem will be in. So it's just a matter of will it be in for mid-year or not? Most probably it will be in because we have time for both electrolysis and OChem. Most probably. So okay, so if there's any homework, do ask them on Sundays. Today we'll try to cover electrolysis in a brief way, so that when you study electrolysis, it will be easier. Bit fair of warning: this thing is complicated not just because of the foundational knowledge, but it is the question itself. The question itself is almost always hard. You will see as we go along. Today, you won't be seeing much question. You'll just be seeing the foundational stuff, right? Okay, so guys, I want you to look at my Jamboard at your laptop screen. So we're going to concentrate more on that. I'm going to share for you the Jamboard also. There you go. Okay, I have shared with you the Jamboard. Please write something in the Jamboard to show that you are in. Write your name, please. Using your mouse is enough. Michael, the first thing will be a quick review for you because everybody have to start here, and then immediately I will introduce all the other things. Okay, Aryan, I can see you. Mike and Noah, your writing, please. Right, I will be needing your video, sure, but let's concentrate on the Jamboard first. Noah and Mike, I need to see your mouse.
Oh, wait, you shared the Jamboard.
I have shared the Jamboard and Aryan already received it. So I'm going to check whether your name is there. Your name is definitely there, Michael Chanbar. Yeah. Okay, Mike. So Noah, where are you in the Jamboard? Okay, cool. Right. Okay, cool. Now we're going to start. So Mike, again, a bit of a revision. So I'm going to ask you to do quite a lot. You are combi. Yeah. Oh, I'm sorry, Noah. You're not covering electrolysis. What am I talking about? Right. Sorry. I forget. I keep forgetting that. So I'll follow your homework using the Jamboard. Okay. Okay now. Okay. So we'll take turns. We'll take turns. Right. So for Mike and Aryan. Mike, what do we have on top here?
The battery.
Yeah. Aryan and Mike, remember that the battery can be flipped, and it is important that you recognize, you will see later. It can be like this. It can be like that. That's the first thing you notice, right? First thing you notice is the battery. Yes?
In my practical, we use like this electric box thing. I don't know what it's called. Correct.
So in the sense that you have to know where's the positive and negative, right? It has to be done correctly, correct? So same thing for, if Aryan, if you have a chance to do the practical electrolysis, not everybody has a chance, but if you have, you will see that the battery orientation is important. So that's the first thing we notice in the electrolysis. Now, the electrolysis job is to do something that is impossible. Let's get this very clear. Electrolysis will revise a lot of chapters. For example, it'll revise redox for you, it'll revise mole for you, it'll revise reactivity series for you. In fact, there isn't much thing new, but they combine it in a way to call the chapter electrolysis. Now you know why electrolysis is the second last chapter, because it requires all the previous chapter. For example, we require the reactivity series. This is how I ask you to remember ... Michael, who's the 3 dot below here? Quickly, the 3 dots below here.
Copper, silver, gold. Okay, I didn't use this method to remember. I used like the acronym thing.
Sure, but I think it's very slow, right? So if it works for you, good. Remember, if it is useful when it is not in exam, but not.
But usually I rip out the periodic table at the back of the paper and I just write down the thing, so I can just refer to it. Then I staple it back at the end of the exam.
Correct. Again, up to you, but do whatever works in exam, not outside exam. So if it works inside exam, then I have no complaint. Right. So Aryan, what is the in the middle?
Is zinc, Fe,
right.
and Pb.
Good. Good. Whatever suits both of you, as long as you get it correct. So group 1, group 2, group 3. Now, electrolysis will do weird things like this. Electrolysis will there's Na plus here, right? Super stable, and there is sodium here, super unstable, super reactive. Electrolysis will do this. This is a super high jump, a super high jump, and this happens in electrolysis. Only electrolysis will do this. Let me repeat. Only electrolysis will do this. So this is very special. We're trying to make sodium metal out of sodium plus, right? Now, let's start with this first. This is NaCl liquid. Now, Mike, what does liquid mean in this case? Have you seen a liquid salt before? Michael? Right. I also never. It's very high temperature. You will never see this in lab because this thing that we're going to describe, Mike, the one that you already know, is super, super dangerous. By the way, Noah, I cannot see your video because I'm trying to follow you, but I don't know what to follow, right? Noah, no? No, are you going to show me your video?
No.
Right, so I cannot follow your video right now. I'm not seeing anything yet. Okay, so, all right. Okay, that's nice. Oh, you're doing chemistry, Noah. I guess if you want. That's right. So temperature is around 800 degrees Celsius. This is very high, not going to happen in lab, not going to happen in practical. Now, liquid means it will be Na plus and Cl minus. Are you okay with this, Aryan?
Yeah.
This is revision. You notice that this is not new. Oh, NaCl liquid is Na plus and Cl minus floating around. Now the battery, right? So let's see how Na plus, which is here, becomes Na. Now, Mike, I teach you what maybe differently from your teacher. The second thing to observe is what? The first thing to observe is battery. The second thing is?
What, the electric current?
No, the electric flow. Just say the electron flow. Just say the electron flow. So help us, Mike, where is the electron flow in this situation? Very good. Very good. So thank you very much. That is definitely correct. Aryan, does it make sense to you that the electron flow is like this? This is physics, by the way.
Yeah.
Okay. Last thing to ask Mike. Okay, Mike, there is no conductor here. Is that correct or not?
What do you mean there's no conductor? Oh.
Okay, this is a wire, right? So electron needs wire to flow, right? And this is also a conductor, a special thing. But this thing, is this a conductor or not?
Supposedly no.
But if it is not, how could electricity flow? Or are we being bluffed by this whole thing?
So is it the Cl minus flows through?
Replacing the function of electron, and Na plus also. However, there's a big but here. But Aryan and Mike, you know that Na plus and Cl minus can serve that purpose, right? Now let me get this straight. Electrolysis doesn't work if this is not liquidy. There is a reason for that. If this is solid, it does not work at all. It must be liquidy or aqueous in other cases. So this is not because we want to make our life difficult or want to try something new. It is because it is necessary. You will see later why. Now, last thing, Mike, help us. Who is this guy? Who is this guy? The simplest thing here is graphite, right? For some reason, you don't see graphite in your lab practice also. You see some weird metal. I'm going to use graphite because theoretically, graphite doesn't react. It just conducts. Again, yes?
Why don't we just use a normal metal? Is it because it's too hot?
Normal metal, which exists here, okay, I'll pose this question. It's a very important question. Alamak, why don't we just use metal? Well, of course, most metal do melt or become soft at 800, but that's not the biggest problem. The biggest problem is that the metal will be consumed. Let me repeat this. The metal will be consumed if you try to use any types of metal except the most unreactive one. So we're going to talk about that in detail later? Very good question. Eh? So now, Aryan and Mike, you know why you're using graphite? Because graphite conduct, but surprisingly, graphite for some reason does not react.
Okay.
Yes.
Then
Yeah.
for the salt solution with water,
Yes,
right?
for the salt.
Because it can conduct because of the water, right?
No, wrong. For example, I can replace this with NaCl aqueous. Now, this is what you do in the lab, right? NaCl aqueous is room temperature, okay? Very not dangerous. That's not because of the water, okay? So there's a H2O here. H2O don't conduct, so to speak. It's still the Na plus and the Cl minus doing the conducting, flying around in the water. Still like that, still the same thing. So if you just have water, the conduction will be extremely bad. That's why you add in the Na plus in your lab practice. Okay. Right. You will discuss that later. Don't you worry. Right. So Aryan and Mike, so far the initial setup clear first.
Yes.
I will mention a metal which does not react again. Platinum. Do you see platinum in the reactivity series, guys?
No.
And that's because platinum is here, and we don't care because platinum don't react. Tara, finish. Do we use gold? Yes, sorry.
What about tin?
Tin is around here. Tin is around here. It does react. It does react quite a lot, right? So we don't use tin. I mean, think about it. We don't even use copper. We don't even use silver. You will see later what that means, right? Gold, we don't use because it's very expensive and it is too soft in this high temperature. So again, useless. Not because it reacts. Platinum and carbon still, I mean, there isn't much other option. Now, Mike, your mysterious metal is probably not platinum because it is too easy to steal. Platinum is very precious also. I'm guessing it's some kind of special thing to steal. Okay, that's my guess.
Yes. The special metal used is an alloy.
For the lab practical that Mike had, I am not sure. I'm not sure.
Oh.
Theoretically, we say graphite or platinum because that's just the easy way out. If I could have platinum, it's ideal. Of course, I cannot, but if I could, it's ideal. Okay, just saying that in real life we won't be using platinum, right? Okay, so far so good, yeah. So far so good. Now, before we continue, Noah, any question right now? Do you actually have a question right now? No, don't mute. No. Do you have a question right now? Do you have a question right now?
Yeah.
Yes or no? Sorry, I cannot hear. Oh, yes. Okay. Now, while I answer Noah's question, because we're going to alternate Mike and Aryan. Mike and Aryan, you set up your video because I now need to see your video because you need to draw this in the paper. So go ahead and set up your video first, right? While I answer Aryan's question. Now, Noah's question. Noah, let me see the full question on top first.
It's just like that. Above is another question.
Oh, wow. That's so weird. Okay. Now, the first thing, Noah, is for this one, you cannot do it without the reaction. Does that make sense?
Yeah.
So part B, same thing. Part A, you need a reaction. Part B, you need a reaction. Do you know the reaction?
I don't know.
All right, then let me write down for you. Now, your problem is therefore you do not know the reaction. I am pretty sure after you know the reaction, you can. So write down CaCO3. Mike and Aryan, again, video and paper. And Mike, you're going to immediately draw everything with the reaction. So arrow, Noah, arrow with heat. Arrow to the right with heat. Write down heat on top of the arrow. So kind of like a lot of heat there. Okay, so on the right-hand side, it'll be CaO plus CO2. If you feel that you need to balance it right now. I'm going to give you the reaction on B first, right? B. Right, so B. B is nitrogen gas. Write down B on B. Nitrogen gas plus hydrogen gas. Do the double reversible arrow. Do you know what I'm saying? Double reversible arrow. Nice, right? And then on the right-hand side is NH3. Again, if you need to balance, you balance it first. And then I think you can start doing it already. Clear now?
Okay.
All right. So Mike and Aryan, where is your video and paper? Mike, if you're ready with your video, I want to see a paper and I want you to redraw this with the reaction because you already know that, right? So that's your revision. Aryan, where is your video?
Yeah, I'm still setting up.
All right. Okay. Right. So Mike, again in a piece of paper, I'm gonna erase this thing, right? I'm gonna erase this thing. Aryan, I'm gonna erase this thing, and you're gonna try your best to recreate things. Huh? Same thing with you, Mike. Same thing with you. So please recreate this quickly. Right. Again, Mike, you should be more complete than Aryan because you have covered this. Huh? Okay, Aryan, the wire is not shouldn't be in the water because the wire is copper and you are avoiding copper. Don't put the copper into the water because then, or the liquid, because then it may react. Does that make sense?
Yeah.
All right. Okay. So even copper, we're trying to avoid. Mike, move up a bit so I can follow. No, are you stuck somehow? Okay, that's nice, Mike. Okay, the electron flow is wrong, Aryan. The electron flow goes from the negative, the short, to the long, and it's very important. Very, very soon. It's very important. Now, Mike, looking good, but I want you to write down the reaction. Which was the cathode, which was the anode. What's the reaction? What's the total reaction? Right. That's just what we cover on Tuesday. Okay. Okay, Noah. Do you have problem balancing? No.
The top one, not this one.
The top one is already balanced. Actually, it's 1, 1, 1. Do you realize that?
Oh, okay.
Right. So that's why, it so happens it's already balanced. It may or may not. Right. For the bottom one, are you done?
Yeah.
Yeah. The bottom one is also no balance. Now, can you use this reaction to answer the question? Can or cannot?
Yeah.
Good. Okay. Ariana is Cl minus, not Cl2 like that. That's wrong. It's Na plus and Cl minus in this case. Okay. Okay. Now, Aryan. So while Michael is doing the rest, so Aryan, the electron flow tells you the reaction. Now, first thing first, we have to determine Na plus go where and Cl minus go where. It's very easy. The Na plus will not go to the positive end. Make sense or not?
Yeah.
It will go to the negative end, right? But the Cl minus will go to the positive end. That's the easy part. So both have their own destination. Make sense? Yeah. Good. Now yours will be a cross. Now this basically means, look, the Na plus is going to meet the electron. Correct or not?
Yeah.
Right. So the first reaction that we write is very simple. The first reaction is Na plus meets electron. Right? Becomes what? Becomes what?
Na.
Yeah, Na. Okay. It will be liquid because it's hot, but this is currently already metal. Please notice that this is iron. And we have just jumped from here to here. Do you notice that, Aryan? We just made the jump. Boom. With the help of electrolysis. I don't know, with the help of electricity. Electricity supplied by this, right? Okay. The second guy is Cl minus, and the electron is telling us that the Cl minus will kena rip the electron. The electron will be taken away from the Cl minus. That is what this is telling us. Make sense, Aryan?
Yeah.
So we write Cl minus minus electron. If that makes sense to you,
Yeah.
Cl minus minus electron will become what?
Cl.
Cl. However, there is no Cl. You learn that there's Cl2.
Yeah.
2, 2, 2. So far, so good.
Oh.
Also, chemistry
Is
don't
it a
like
gas?
mine. Sorry. It is a gas. Yes, it's a gas.
Is it a gas?
It is definitely a gas, the chlorine gas that we know, right? However, chemistry don't like to write minus 2e. He does not like, even though that is exactly what's happening. Let me repeat that. What is happening is the electron cannot taken away from the Cl minus. I can confirm this, but the chemistry does not like to write it that way. The chemistry likes to write it like math. We move to the right plus 2e.
Oh, yeah.
Does this make sense? It's like door,
Yeah.
just put it to the right. So I don't know why we don't write it that way, but we don't. We write this way, but the meaning remains. The meaning is minus 2. Understand?
Yeah.
Now sum everything up. When we sum everything up, we have to do this first. We have to times 2 times 2 times 2, because plus 2e plus 2e, they must be the same. And then they can cancel. It is very important to cancel. What does this tell us? This tells us something like this. Michael and Aryan, what does plus 2e plus 2e tell us? Very simple. 2 electron go in, 2 electron go out.
Oh.
That is what he's telling us. It cannot be like this. It cannot be 1 electron go in, 2 electron go out. That does not work at all. Understand?
Yeah.
Also, it cannot be 2 electron go in, 1 electron go out. It must be the same one. It must be the same one. Can you accept this?
Yeah.
That's why times 2 times 2 times 2. And then when you sum up everything, Michael has done it correctly. Yeah. On the bottom, you have 2Na plus together with 2Cl minus will become 2Na, in this case liquid, plus Cl2. The electron, quote unquote, disappear. It is still there doing the work, but it quote unquote disappear. This is called half reaction, full reaction. Right? The last thing to talk about is the positive ion is cation. Am I correct, Aryan?
Yeah.
So we call this the half reaction at cathode. Why do we call this cathode? Cathode is the place where the cation go. Simple, simple. This is at anode. Why do we call it anode? Because it is the place where the anion go. Simple. Okay.
Yeah.
Okay. Michael, any part? This is what we covered yesterday, right? Right. Now I will give you the more complicated one. Are you ready, Aryan?
Yeah.
Yeah. So moving on to Jamboard page 2. Before we do that, Noah, any questions so far?
No, I'll
Right.
move on to email.
All right, sure thing. Be happy to. Now, in page 2, I am drawing something similar, right? I'm drawing something similar, but for variation purpose, I flip the battery. I now flip the battery because, you know, the question can do that. That's the first thing. What is the second thing we observe, Aryan? Aryan, the first thing we observe is the battery. The second thing we observe is?
The liquid?
No, the electron flow. The electron flow. The electron flow is the second thing we observe. Okay? Okay, yeah? The third thing is the liquid. Now the liquid changes. I will now present to you, Michael, the liquid you have in your lab experiment, but this setup will be simpler, so easier to understand. I present to you NaCl aqueous, room temperature. We have Na plus, we have Cl minus. By the way, we have H plus and OH minus. Aryan and Mike, this is the first difference. The first difference. Do you notice any other difference between this and the first guy? What are the differences that you notice, Michael? Between this new setup with the first setup, which is simpler. The first setup is simpler. It's the same at both, right? Both have Na plus and Cl minus.
But now they also have H plus and OH minus.
Where does this H plus and OH minus come from, Michael?
The water.
The water. Aryan, does this make sense? Michael is correct. Does this make sense?
Yeah.
Okay, Michael and Aryan, water does contain H plus in a very small amount and OH minus in a very small amount. It's a small amount, but it exists.
It is. Yeah.
Okay. Any other differences? Nothing much, except for the room temperature. Right? The battery is still there. The electricity is still there. The conducting electrolyte, the liquid is called electrolyte, is still there. Now, what is the third thing that we observe? The third thing that we observe is how the positive and negative go. So Michael and Aryan, these two guys will go here or will go there. Which one?
The right.
To the right, yes, because the right is negative. So we do that. These two go here, these two go there. So far, so good. Now that's the third thing that we observe. The fourth thing, now this is more difficult. We're writing the half reaction, right? We're writing the half reaction. This is now more difficult. Observe, Aryan and Michael, there is a competition. Aryan and Michael, there is a competition. Who is going to get the electron? Right? Let me repeat the reactivity series. Dot, 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 dot. Aryan, where is Na?
All the way at the top.
And therefore, where is Na plus?
All the way at the bottom.
Right. Now, where is H? Where H is here. Where's H plus? H plus is here. Who will win, Aryan?
The one with the bigger jump.
No, the bigger jump is harder. You know lah.
Oh.
I hope that makes sense. The bigger jump means more energy. So you know what? The smaller jump wins. If that makes sense, that means the smaller jump is easier to do lah. Something like that.
Yeah, yeah.
Okay. Michael, does this make sense?
Yeah.
Let me repeat this one more time.
It's only the bigger jump when if it's the opposite way around.
Let's not call that jump. That's bigger drop. Let's call that a drop. A drop is different from jump. Okay, makes sense. Huh? A jump is a jump. A drop is easy. A jump is hard. Now, there is one thing to consider. Actually, only most of the time H plus win. Sometime, just sometime, Na plus win. Sometime. Do you know what happened when Na plus win? Na plus win, he become Na, right? Correct or not? Na plus electron, right? Plus electron become Na, correct or not?
Yeah.
The Na immediately react with the water. He become Na plus again.
Oh.
So there is two problems. The Na plus, first of all, have to jump very high. And after he jump, he cannot react with water immediately. Useless. The water simply prevents Na from happening. It simply does that. Understand, Michael and Aryan?
Yeah.
Whether whoever gets the electron, in the end, hydrogen wins. Because what happened when Na react with water? Hydrogen. Same thing, right? So no matter what, hydrogen will win. So we'll write here, H plus plus electron becomes what, Michael? That. No win. Yeah, becomes H, but there is no H, so H2, right? 2, right? 2. Now, this is for Michael, right? Since Michael have done this reaction. Michael, this is the source of the purple color. The H plus is being consumed. It becomes more alkaline. So this becomes more purple. No? That's why. Okay, understand? Right. Now, the negative still have a question mark. So now, my question to you is, guys, Aryan and Michael, do you have any idea who negative will win? Win meaning will the electron will be taken away from them. That's the definition of winning for them. Do you know who will win?
Is that like no winner?
No, somebody will win, because if nobody win, no electron will be taken, no electron flow, no electrolysis. Let me repeat this one more time. Electrolysis must happen both way. It cannot happen one. It will stop immediately. So this happen, this must happen also. Just to be clear. If not, electricity will not flow. Okay?
Yeah.
Right. So somebody will win. But how do we know who win, Michael? Aryan, how do we know?
No idea.
Right. So this is what the lab hasn't covered. Now this is called the metal reactivity series, correct? Metal reactivity series. Now metal reactive series involves cation, correct or not? The metal is on top, the cation is on the bottom. Now it's always positive, correct?
Yeah.
There is also the anion reactivity series. So which contains all the negatives here and all the non-metal here. So you call that the non-metal reactivity series, right? In the non-metal reactivity series, you have OH minus and Cl minus. You have OH minus and Cl minus, and one of them is on top of the other. You have never seen this reactivity series before. Now, Michael and Aryan, I invite you. Do you have your textbook, your chemistry textbook at home? If you have it, please open the electrolysis chapter and find this, so to speak, non-metal reactivity series. Please do that right now and show it. Okay. Noah, any questions so far? Noah, any questions so far? I think you're muted, Noah. No, any questions so far? Sorry.
No.
Okay, zoom in a bit, please. Zoom in a bit. Nice. Okay, thank you. Michael, Aryan, just checking, you're taking your textbook, right? You have the textbook or no? If you don't have, tell me lah.
I don't have the textbook.
Yeah.
Oh, right. Okay. Mike, do you have the textbook?
What are we supposed to find?
Go to the electrolysis chapter.
Wait, can I go and find?
Yes, Aryan, but just take 1 minute. If cannot, then I'll still tell you lah. Don't worry, I'll still tell you, right? So, Michael, do you have the textbook? If you have, show it to me, the electrolysis chapter.
Yeah.
It should be the one of the last few chapters.
I don't have my textbook.
Understand. So, Mike, if you have it, we'll wait. If not, I'll just tell you. Mike, do you have it or not?
Yeah.
All right. Put it on the camera. Put it on camera. I'll ask you to flip, and then we'll just go. Okay. Flip. When you see the series, yeah, you see the series, you'll see it immediately. One. Okay. Don't have flip. Right. Don't have flip. If you see a series, no, don't have flip. You should see it immediately when you see it. It's not, no, actually at this point, you should have it already. Are you sure that you don't see anything? No negative series. That there should be something before the H2SO4 one. Don't have it. Really? Okay, this thing, stop here. The concentrated sodium chloride, right? Then on the next page, select, right? On the next page, show me the next page. Right, this the selective. Oh, there it. No. Go up. Show me the up part. Show me the up page, the upper part. That is also not the case. So how come your text how come your textbook doesn't show any negative reactivity series? This is so weird. Oh my goodness. This is not. No. Yeah, it should be showing you early, not later.
There's not even one. So.
Okay, never mind. I'm gonna show you. Something. So, which one is more reactive, Aryan? Cl2 or Br2? Any idea? Cl2 or Br2? Any idea, Aryan?
Which one is
More
like
reactive.
more?
More reactive. Yeah.
I think Br2.
No, it's Cl2. Chlorine
Oh, yeah.
is reactive. Okay. How do we know? Well, by experience, but that's a very painful experience, so we don't do that. Or by knowing from chemistry. That's part of what we're learning. So I hope it makes sense if I write here Br minus and Cl minus like that. First thing first, okay?
Yeah.
Okay. So H2O, right? H2O compared to Cl2, a chlorine gas. Who is more reactive, Michael?
CO2 compared to chlorine.
No. H2O, like water. Water compared to Cl2. Who is more reactive?
Chlorine.
Yep. So I write H2O here. I hope that makes sense. That's just how we write reactivity series, right? The lesser reactivity on the bottom, correct? Now, surprise, surprise, this will be OH minus. Well, it's not H2O, it's O2. So how should I write this down for you? It's gonna be like that. It's gonna be am I writing this correctly? Am I writing this correctly? Never mind. You'll see the reaction very soon. I should. So I've put the OH minus here. And I put the Cl minus here. Now here comes the surprise lah. Here comes the surprise. Now, in the reactivity series, we say something like this. Okay, theoretically, OH minus will win. Theoretically, Cl minus will not win. But actually, both have a chance to win. It's a matter of who wins more, who wins less. In the positive side of things, the Na plus can sometimes win. The problem is it will automatically react back. That's the problem. So he does sometimes win. It's not that he cannot win. It's not true. Okay. So in the OH minus and Cl minus, both can win. Now OH minus will win easier. Cl minus will win harder. Now I write here. If things are dilute, OH minus wins. We assume that way. If things are concentrated, Cl minus will win. That's just how we assume to make it simple. Does this make sense, or do you have to memorize, Aryan?
Yeah, I think it makes sense.
Okay, then let me explain just to be very clear.
Can you repeat what you just said?
All right, so dilute. Now, when I say the NaCl is dilute, what do I mean by, the NaCl is dilute? What does that mean, Michael?
It's not that concentrated.
Yeah, the NaCl is not very concentrated. You think carefully, that means the water ratio is more. Yeah. There is more water, a lot more than NaCl. So there is a lot more OH minus. I mean, kind of something like that. So by crowding effect, OH minus wins more than Cl minus, just because there is more. If that makes sense. So if you increase the concentration of Cl minus by, increasing it, then suddenly Cl minus wins more because less water compared to Cl minus. Something like that. That's very roughly. Make sense?
Yeah.
Now, surprisingly, guys, I will now tell you this. This is the last thing I'll tell you. If it is dilute, OH minus wins, right? After a while, the water content will decrease because the water keeps being consumed, and then suddenly you will have a concentrated thing. Then Cl minus start to win, and then OH minus win again, and then Cl minus will win again. They just go back and forth, something like that. Okay, you'll see again later. Now I'm going to write down the simplest reaction first, which is Cl minus. Cl minus minus electron equals to Cl. Wait a minute, I've seen this before, right? I have seen this before, correct?
Yeah.
This is what happened in the previous guy. The OH minus reaction is slightly more complicated. The OH minus is slightly more complicated. OH minus will become something like an O2. There'll be an oxygen here. right? We will talk about this maybe on Sunday because there isn't much time already, right? So put a question mark here. Now, before we end, I want you to compare the first setup and the second setup and the first setup. We're gonna talk about the differences. What are the differences between the second setup, this one, and the first setup? Aryan?
Is it because there's 4 types of ions?
Correct. You have to consider 4, and there'll be competition. You have to determine who wins. Correct. That's the first thing. All right, Michael. What else? What other differences do you notice
Sorry, between what?
between this second setup and the first setup, which is simpler? No other differences.
Other than the one that Aryan mentioned.
Yeah. No. I mean, let's talk about in detail. What happens in the what happens in this part of the reaction, like the positive one? The first guy. What happened?
The first guy.
The first setup.
Yeah. The first setup is
It's in front of you. It's in front of you. It's in front of you.
Yeah, the first setup is Na plus
becoming Na lah, right?
to
And
Na,
first
yeah.
becoming Na. The second setup, I tell you, there is no way that's happening.
Okay.
Only hydrogen will result. So you think this about this category, yeah? Aryan and Mike, how can we make sodium metal? How can we make sodium metal? The answer is electrolysis. But now you must answer in more detail. It is just any type of electrolysis. It must be the first setup. The second setup will never produce the sodium metal, no matter what you do. Does that make sense, Aryan?
Yeah.
Okay. As for the production of Cl2, actually, we usually do not want to produce Cl2. That's not very interesting to us. Usually, actually, for example, we may want to produce oxygen. I know we have a lot of oxygen, but maybe in space or whatever, we want to produce oxygen. My point is oxygen and Cl2 is not very interesting, but usually people want to produce oxygen more than Cl2, usually. So this one is more interesting, although we're going to study both, of course. Lagi, anyway, Cl2 is produced here, possibly, and also in the first setup. And it's, again, not very interesting anyway, usually. Okay, now, I will close with the question in the third page, okay? The third page. Look at this setup. Is this setup like the first one or like the second one? Third page. Like the first one or like the second one? Michael, what's your opinion?
First one.
What's your opinion, Aryan?
It's the first one.
Okay, then Michael, what do you expect to be produced here? Aryan, what do you expect to be produced here? What's your answer?
Ne and Br2.
Yes, the reaction you can write down exactly like by observing the electron. Does that make sense?
Yeah.
Okay, so can you produce sodium another way? You can use NaCl, you can use NaBr. I guess the difference is the gas itself, I suppose. Okay, now we're only touching around 40% of electrolysis, and we'll try to continue again on Sunday. Okay, Michael, Aryan?
Yeah.
There's nothing else. I'll see you on Sunday. Don't forget to rest on Friday and on Saturday. Okay, bye.
Bye.
Noah, can I answer your last question if there is any?
No.
All right. You're doing like exceedingly more complicated stuff with all the trigonometry and stuff. Are you feeling that this is getting more boring, or you still feel the challenge, or you feel that why am I doing this? What's the feeling currently?
I still feel the challenge.
So I suppose that kind of positive, like not too hard of a challenge, right? Just a good challenge. So that is a very good preparation for the exam, that one I can tell you. Right? Any news on the mid-year or whatever?
No.
All right, understand. Then I'll see you on Sunday. Don't forget to rest on Friday and on Saturday. Okay.
Okay.
I'll see you. Bye-bye.